Hi guys, let's go to the second topic, which is refraction. Now I'm sure you've seen this before while you're drinking. If your water is clear, you can see that your straw is bent. So how does this happen? This phenomenon is called refraction, where when the light goes from a different medium to another medium. So let's say light passes through air. So I have an index of refraction of air here, and then it goes to the surface of the water, and then went into the second medium, which is water. So since air and water have different index of refraction, the light will be bent, and the angle would not be the same as reflection, where the incident and refracted angle is the same. For refraction, the angle would be different depending on the different types of medium. So for refraction, let me show you an example of refraction. Here you can see two different types of medium where light passes through from air, where we have diamond as well as water. For diamond, the index of refraction is much higher as compared to water. Therefore, the refracted angles will be different. So what is index of refraction? Index of refraction is actually the ratio of the speed of light in vacuum to the speed of light in medium. Do you still remember what speed of light is? The value will be 3 times 10 to the power 8 meter per second. And the equation of this index of refraction is C over V, where your C is the speed of light just now, and V is the speed of light in the medium. Both value unit will be in meter per second. So if you cancel that out, index of refraction wouldn't have any unit. And index of refraction should never be lesser than 1. Let's do an example here. A fused quartz has an index of refraction of 1.46. Now, calculate the speed of light passing through it. Speed of light in vacuum is 3 times 10 to the power of 8. So let's take out all the values here. Index of refraction is already given, which is 1.46. And the speed of light is what you need to find. Passing through it, meaning passing through the medium. So you have to find the V. Speed of light in vacuum is your C. So N is equals to C over V. Find your V, which is C over N. And you will get 2.05 times 10 to the power of 8 meter per second. Alright, so try and do these two exercises. If you have any question, you can come to me. Showing you another example of refraction if it goes through 3 different types of medium. Now, let's go to the first surface, which is between air and glass. So this will be your first surface. So light ray will pass through. This will be the incident ray. And of course, the incident angle will be between the normal line and the light ray. So this will be your theta I. And then the light will be refracted because 2 different types of medium, 2 different types of index of refraction. So where would the angle of refraction be? Again, it will be between the normal line and the refracted ray. So this is my theta R. And then the light will stop here and pass through between the boundary of glass and air. This will be my second surface. What will be the angle of incident at the second surface? It will be between the incident ray here and of course the normal line. So this is my theta I. And finally, the refracted ray will be between the refracted angle will be between the refracted ray and the normal here. So it will be theta R. Alright then, let's go to Snell's law of refraction. So what is Snell's law of refraction? If let's say one of those values are not available, so how do I calculate them? We can use this equation, which is N1 sine theta 1 is equals to N2 sine theta 2. So N1 will be your index of refraction of the incident material, the first index of refraction, where your first light ray hits, and then your theta 1 will be your angle of incident. N2 is your index of refraction of refractive material or your second medium. Theta 2 will be the angle of refraction. Let's try an example here. A beam of light of wavelength 500 nanometers, so we have our lambda, traveling in air incident on a slab of transparent material. The incident beam means your incident ray, makes an angle of 40 degrees with the normal. We'll draw that first. So I have a surface here, draw the normal line, and then the incident ray. So where would the angle be? Between the incident beam and the normal. So here's the incident beam. So which one will be the angle? So the normal to the line is here, and this is the incident ray. Therefore, this will be the angle of 40 degree. And the refracted beam makes an angle of 26 with the normal. So let's say this is the refracted beam to the normal, meaning from here to here, this will be 26 degree. So use that inside your equation, n1 sin theta 1 is equals to n2 sin theta 2. Substitute all the values. N1 is your incident index of refraction of the first medium, which is air, and then times sine 40, which is the incident angle, divided by the refracted angle, sine refracted angle, and you will get 1.47. So try and do this exercise and then check your answers. Let's go to the refractive index of water with respect to air. Now I'm sure when you go to the swimming pool, you would notice that the depth that you see of the swimming pool doesn't look that deep. It looks quite shallow as compared to the actual depth or the real depth. So from here, we can actually calculate the index of refraction of water. For example, let's look at this person here. He's looking at a fish. From his view, the fish looks quite close to the surface of the water. But the actual fish, the actual image of the fish, the actual position of the fish is at the bottom here, which is much further as compared to what he sees. So this here will be the apparent depth, whereas here will be the real depth. So the equation will be real depth of object divided by the apparent depth of the object. Let's do an example. A swimmer has dropped her goggles to the bottom of a pool at the shallow end marked as 1 meter deep. So this will be your apparent depth, because that's the actual depth of the pool. But the goggles doesn't look that deep. How deep do the goggles appear to be when you look straight down into the water? So the key word here, how deep does the goggles appear to be? Meaning, they want you to find the apparent depth. Index of refraction is already given, so n is equals to real depth divided by apparent depth. So take out the apparent depth, which is what you have to find, and you will get real depth divided by the index of refraction. So 1 divided by 1.33, you will get 0.75 meter. So that will be the actual, the apparent depth that you see. Okay, let's do a recap here. Do you still remember how to calculate index of refraction? What will be the formula? Yes, it will be n is equals to c over v. How about Snell's law? Correct. N1 sin theta 1 is equals to N2 sin theta 2. Last but not least, refractive index of water with respect to air. Yes, remember, N is equals to real depth divided by apparent